Hello sir, I am Dr. T. Babu from the Department of Electrical and Electronics Engineering, St. Joseph College of Engineering. Today we can see the basics of system. There is a control system concepts. Before get into the control system concept, we must know the basics of system and the organization of the system and the classification of system. So first first of all, the word system, it can be defined as an object which can able to perform a particular job or function by organizing certain number of components in a specified sequence, then that is called system. So system can be defined as an object which has to do certain function by connecting certain number of components in a particular sequence. That is called system. If the response of the system is in a controlled manner, then it is called control system. That is the basic definition of control system. So this control system can be broadly classified into two categories. One is open loop system and another one is closed loop system. Open loop system and closed loop system. In the case of open loop system, there will be no feedback. If it is the system, there will be an input and you will be having some output. The output will not meet the requirement or not, that will not be taken care by the system. For the given input, it will produce the output. That is called open loop system. So all the open loop system will be completely stable at all the time. But in the case of closed loop system, here it will have a system. It will be having some input, it will be having some output. This output will be measured by means of a sensor. Whether it meets the requirement or not, it will be compared with a reference value. When the reference value or the required value or the set value is equal to the output, then this input will be maintained as the previous value, so that the system will produce the expected output at all the time before affecting any external disturbances. So the system will have a feedback, mostly the negative feedback. System will have a feedback, mostly the negative feedback for stable system. If the system has a positive feedback, then the system may or may not be stable, or mostly the system will be in oscillating condition. The output will be in oscillating condition. So the best example for positive feedback system is oscillator. most of the other kind of stable system will comes under negative feedback system. So the question of stability will be there with the closed loop system. Also it is a complex system compared to open loop system. So this system can be designed according to the user requirement. The closed loop system can be designed with respect to the user requirement. So the system will be again classified with respect to the types of inputs and outputs. So the system can be classified into based on input and output. And the type of response, whether it behaves a linear responsibility or linear response. Suppose if the response of the system is linearly proportional to the input, then that system is called linear system. If the output is varied in a continuous manner, then it is called linear continuous system. If it is discrete manner, then it is called linear discrete system. So likewise, we can able to classify the system with respect to the response of the system. If the response of the system is linearly vary with respect to input, then it is called linear system, which can be experimentally proved by conducting superposition theorem. Suppose if the system obeys superposition theorem or superposition principle and homogeneity principle, then the system is said to be linear system. Please note it down that when a system obeys superposition principle and homogeneity principle, then the system is said to be linear system. Otherwise, the system is said to be non-linear system. In the practical cases, most of the system will be linear for short range, not the entire practically possible range. It will be within the particular range, it will behave as linear. So most of the system will be designed according to the range. For example, if I am going to play in a room from morning 8 to 3, then that system has to be ensured between 8 to 3. If it is 8 to 3, in between that 8 to 3 time, the system, if the system is linear, it is more than sufficient. Likewise, only with the linearity will be ensured for this all the system for all the cases. So again, the types of or nature of input, the system can be classified into mechanical system, second one is electrical system, third one is hydraulic system, fourth one is pneumatic system, fifth one is electromechanical system. Again, it is depends upon the kind of system or components available within the system. Suppose if the mechanical system or any system rotates, whether it is having a rotational body, then this mechanical system will be considered as mechanical rotational system. Otherwise, if the system moved in a linear manner, then it is called a translational system. So, the mechanical system can be classified into two categories: mechanical translational system, mechanical rotational system. So, in the case of electrical system, it will have electrical component like resistor, capacitor, inductor, something like that. Then hydraulic system, it will be having the pressurized oil or liquid will be a playing medium, then it is called hydraulic system. Suppose if the playing medium is pressurized air, then it is called a pneumatic system. Then suppose if a system is having both electrical system as well as mechanical system, then it is called electromechanical system. Most of the time the system will exhibits the electromechanical nature. The electrical input will be given, the output will be the mechanical energy like a motor, then it is called electromechanical system. Suppose if I want to control the speed of the motor, so I may design a controller which may be either electrical nature or mechanical nature. That is mechanical nature mean kind of hard braking. That braking will lead to reduce the speed. If it is electrical braking means, then the input voltage to the armature or field will be varied. With respect to that, the speed of the motor will be varied. Then that is called electrical system. And similar way, we can elaborately discuss about the various types of systems. Again, let me come to the next important thing, that is a linear continuous system. So, we know very well that most of the physical system responses will vary with respect to time, then that is called linear continuous system. So, continuously the response of the system will vary, but in a linear manner, then that is called linear continuous system. Most of the time we are assuming that it is linear and as well as continuous system. It need not to be exhibited in all the time instant. So, most of the time the linearity will be failed, but within the particular range the linearity can be ensured. Then the continuous system, the response of the system will vary with respect to time, that is called continuous system. Then this kind of the system will be analyzed by using the Laplace transform. What is the reason behind it? Means whenever a system described by the function f of t, if it is going to be taken as a Laplace transform, then it will be equal to, that is f dash of s, where s is the Laplace variable. This Laplace variable plays a very crucial role when we are doing the initial value theorem and final value theorem. That means, suppose if any system is running continuously without knowing the end point of time, then there I have to apply final value theorem. Suppose if I doesn't know when the system is getting started, then it is where I can apply initial value theorem. So, here the f dash of s will be equal to some minus infinity to infinity e power minus st and f of t dt. From which, from this expression, we can easily understand that whenever this signal varies from at least the t1 instant to t2 instant, we can analyze the system with the help of Laplace transform. Unless otherwise, if a system nature is a discrete manner, if the system response is in discrete manner, then I have to use the Z transform. What is the reason behind to use the Z transform for discrete system means? Since the Z transform of any function will be equal to summation means sum of this instant plus sum of the next instant plus sum of the next instant. That means we need not to worry about the intermediate variation between the first instant to next instant or nth instant to n plus 1th instant. But in the case of linear continuous system, we cannot omit any point between the time t1 to t2. But here it is not like that. The first instant response plus second instant response plus third instant response, like that. So, that is why the linear continuous system will be expressed by using the differential equation. But in the case of discrete system, the same system can be represented with the help of difference equation. There is linear continuous system will be represented with the help of differential equation. This will be done with the help of difference equation. So, the differential equation can be analyzed with the help of Laplace transform. The difference equation can be solved by using Z transform. That is why in engineering concepts we will apply the Laplace transform and Z transform for that particular category. That is particular category in the sense, for linear continuous system we will apply differential equation. For linear discrete system we will apply difference equation. Okay. So, here we are talking about only linear system, not talking about non-linear system. So, when I can say the system is said to be non-linear means, whenever the system does not obey superposition principle, and homogeneity principle. So, if any system obeys these two principles, then the system is said to be linear. A system does not obey these two principles. Any one principle failed means again the system is said to be non-linear. So, this system has to be analyzed with the help of some technique. there is a singular point and so and so analysis, and that will be taken care by writing the state equations, and the formality of controllability and observability, the design of controllers, everything will follows between with respect to that particular criteria. So whenever a system obeys superposition principle and homogeneity principle, and then that system is said to be linear system that can be analyzed with the help of differential equation based Laplace transform and difference equation based Z transform. So these are all the different types of system and the analyzing technique. Okay, so here one more point: to analyze any system we need a function that is called the transfer function. There is the transfer function. It is nothing but it is a function, or it is a kind of equation which is going to represent how the input signal is converted into output signal. How the input signal, how the given input signal is converted into output signal. Suppose we want to get the intermediate component, that also possible by getting the signal, intermediate signal. So the definition of transfer function is nothing but the ratio of Laplace transform of output to Laplace transform of output to Laplace transform of input with zero initial condition. If the condition zero initial condition failed, then again the representation of system using Laplace transform is failed. Sorry, transfer function is failed. In that particular case, again I have to go with state equations. If these conditions are not met by the system, then I have to go with state space approach. So here we have a clear cut definition for state space approach. Whenever a system would not be able to represent by using transfer function technique, I can go with state space approach. Even the non-linear system can be represented with the help of state space approach. So I want to narrate a clear cut point of that what for I need to go with state space approach. The transfer function, as I said, the transfer function approach is applicable only where the system has zero initial condition. Approximately or appropriately I can describe that. Suppose if I am having a capacitor in a system, if it is connected with any input, electrical input, definitely even after removing the power supply, input power supply, there will be small amount of charge will be stored in that particular capacitor, which indicates that the system doesn't have zero initial condition. Approximately we are assuming that the amount of voltage drop in the capacitor is zero. With that assumption only we are modeling the system and analyzing the response of the system wherever we are having a system with a capacitor. Similar way inductor also. So both the case, again whenever we are modeling a system, we are doing certain assumption. That based on the assumption only we can able to derive the transfer function. Based on the transfer function I can able to analyze whether that system is stable or unstable, or whether a controller can be designed or not, possible or not, whether we can able to assess which state variable leads the system into unstable, or which state variable has to brought to the stable region. Everything can be analyzed with the help of the state space approach. We know very well that it is called pole placement technique. Okay, let it be. First of all, I want to give certain brief about state space approach. In the state space approach, particularly what for we need to go with the state space approach means, whenever a system could not be able to meet out the basic requirements for the transfer function technique, then I have to go with state space approach. Particularly when the system order is high. Suppose if the order of the system is say 4 or 5 or 6 or more than that, then to get the response of the time response of the system or frequency response of the system, I need to solve some fourth order differential equations. But we know very well that it is very some complex nature. In the case of first order system, it is so easy. By taking a simple integral, I can able to get the response of the system. If it is a second order system, then I can able to apply some technique to get the solution for that by getting some complex function and particular integral. By sum of these two things, I will be getting the complete solution for the second order differential equation. But for the third order system, for the third order differential equation, fourth order differential equation, we don't have the easiest way to get the response of the system. That is why we need to go with the state space equations. So the basic approach of the state space equation is nothing but there is a nth order system can be represented, that is nth order system can be represented by n number of first order system. Please understand that. Say 10th order system means 10 number of first order system, it can be converted. After converting it into, we can write the state equations are x dot equal to ax plus bu and y is equal to cx plus du. These two are called state equations. These two are called state equations, where x is nothing but state variable. I may have n number of state variable, so like x1, x2, x3, x2 up to xn. The first derivative of all the state space or state variable has to be used to pronounce the first state equations. So that is called x dot equal to ax plus bu, and second equation y is equal to cx plus du. Y is nothing but the response of the system or output of the system, and where A is called state matrix. A is called state matrix, and B is called input matrix. And C is called output matrix. And D is called transformation matrix. Most of the time, most of the time, the A matrix will be a square matrix. B matrix will be a column matrix. C matrix will be a row matrix, and D matrix will be a zero matrix most of the time, unless otherwise there is a input or called disturbance which affect the response of the system directly without affecting the internal state of a system, without affecting any internal state of the system. If any one input or disturbance affect the response of the system, in that particular case only the D matrix will be non-zero matrix. For all other condition, D matrix will be zero matrix. For all other condition, D matrix will be zero matrix. Okay. So, sir, what is the use of this state space equations means? Yes, by using the simplest technique, by instead of solving nth order system, we are converting it into n number of first order system. By applying the basic concepts of matrix theory, we can able to get the easiest form of solution. Easiest form of solution. Since we are going to use the matrix concept, we need not to worry about what will be the complexity. Whatever may be the complexity, a simple matrix is going to eliminate or drastically reduce the complexity of getting solution. So, it is the easiest way. Okay, let it be. So, to analyze a system, we must know what do you mean by first state variable. State variables are a physical variable, or whether it is a measurable or not measurable variables, which can be used to represent the system. But a system may have n number of variables. I need not to consider all n number of variables to represent the system, but predominantly require certain variables to represent that particular system. Without considering those elements, we cannot represent the system. Otherwise, in symbol, I can define the word state variables are, it is a minimal set of variable. It is a minimal set of variables by which we can represent the response of the system. We should be able to, by the state equation, we should be able to get any intermediate stage of the particular system. That is the beauty of this particular state space equations. So, by using this state equations, I can able to get the state transition matrix. That means internal transition state can be estimated by using the state transition matrix, that is called the e power at, where A is the state matrix, E is the exponential term, it is vary with respect to time, that is called e power at, that is called state transition matrix. So, by using the state transition matrix, I can able to estimate what are all the intermediate stage in that particular system, where the lagging is there to get the expected output, or that which particular intermediate stage lead the system to unstable. Everything can be estimated by using the that is called state equations. Okay, then by using this, I can able to determine another one important thing, the controllability and observability. Observe. That means whether I can able to design a controller for that particular system or not, whether it is possible to design the controller or not. That can be estimated before designing the controller itself. We need not waste the time of a particular engineers. We need not to spend such a certain system, we could not be able to design controllers. For such a system, I can able to estimate whether the system can able to design the controller or not. That can be estimated by using controllability technique. And similarly, I can able to estimate whether the system state variables are measurable or non-measurable. That is called observable. Observable is nothing but whether it can be estimated either directly or indirectly. We need not to worry about the direct measurement or indirect measurement. Indirect measurement means certain quantity which could not be able to measure directly. Certain, for an example, the flux density. So, in the motor or any coil, we cannot measure the flux density directly. We do not have any measurement device. We have the internal factors of that particular flux coil dimension and the circumference area and the amount of current flow through, and the amount of voltage drop across, everything. If we know these parameters, we can able to estimate the flux density in that particular coil. So, it is also possible to measure, that is called indirect measurement of a particular quantity. So, if any system has a state variable, I can able to estimate either directly or indirectly by estimating the observability technique. So, it has both two techniques of controllability and observability. One technique is called Kalman technique and another one is called Gilbert technique. In this Kalman technique, I can able to estimate whether the system is either controllable or observable. It will not tell anything more than that. But in the case of Gilbert's technique, I can able to determine whether the system is controllable or observable, as well as if it is not controllable, which state variable leads the system to uncontrollable. That can be estimated by using Gilbert's technique. Similarly, which state variable leads the system, which state variable lead the system to unobservable. That means which state variables are unable to measure, that is called observability. So, all these things can be estimated by using the state equations. So, with this I am concluding the various types of system and its classification, the analyzing technique, and for the linear system concepts, and that if the linear system is failed, then what will be the case, how it can be estimated. Suppose when the system does not exhibit zero initial condition, I have to go with state space approach. So, what are all the basics of state space approach? All these things we have discussed in this class. Thank you.